Hello, everyone. Welcome to the first in a series of discussions Expero is hosting relating some of the lessons we've learned in the field, modernizing legacy software for our clients. While good product development practices are universal, some of the tactics, tools, and strategies are different when we're dealing with legacy software as compared with greenfield development. I'm Sebastian Good, a co-founder at Expero and a developer at heart. And joining me today is Chris.
Hi, this is Chris. I'm a developer at Expero, and I work with distributed systems and doing some dev operation work.
I first want to spend a minute explaining just what Expero does so you can put us in context. Our typical engagement is not to build a museum website or digital experience. It's to work with highly qualified domain experts working on typically complex problems. A typical product for us would be a new platform for trading US Treasuries, or a software package for helping geophysicists find oil underground. We work with domain experts at companies or the domain experts that companies are trying to reach to build solutions to help them do their job. Our typical customer needs a full complement of the sorts of specializations needed for this work. And today's talk will be primarily focused on technical strategies, but in the future, we'll be talking about commercial considerations, user experience challenges, training, and even the surprisingly common puzzle of figuring out just what your legacy software does. The work we do is typically done for fairly large companies that have the size of data or the size of problem or payoff that justifies building complex software. We'd love to hear from you about what kind of problems you're solving. So first, a few definitions. What in the heck do we mean by escaping an enterprise prison? In our case, we're trying to be a little silly about it, but the idea is a lot of very important, very useful software has been built with an infrastructure assumption that is slowly becoming out of date. Namely, that there's a large corporate firewall and everything of importance sits inside it, and that all the hardware you're going to use sits inside the corporation as well in a data center that you lease yourself. The problem with this set of assumptions is that the world outside that firewall, where it was once bleak and quiet, is now actually vibrant and wonderful, and you're probably having trouble getting people to come work inside what we call that corporate prison. And this presentation is about some of the tools and tactics that are now available in this new mindset. And I thought we'd also mention that when most people talk about legacy software, they're using fancy words to maybe be a little insulting about it. Legacy usually doesn't mean anything particular other than the guy who calls it legacy doesn't want to work on it anymore. Maybe there's a newer, cooler programming language. Or when they call it a monolith, what they mean is it's big enough to where it's hard for them to understand at first glance. And there's legitimate criticisms that can be leveled at really large, complex pieces of software. But for us, we like to keep in mind that this software is here because it's useful, because it's important. So we're going to be talking about some steps you can take to get something like a legacy monolith, something that maybe is now hard to develop in, and some of the tools that can help you if you take it outside that prison. We're going to talk about two major areas of improvement, one operational and one focused on software. And these are some of the common complaints you'll see around software that's important enough to keep around, but large enough to start being difficult. To start us off, we're going to have Chris talk about some of the operational strategies.
Thanks, Sebastian. So what I kind of wanted to go over today was just, how can we migrate from our locally installed on-premise data center solution and maybe move towards a cloud, and how we can actually, utilize the cloud to improve our ability to deliver our software. Next slide. So some of the common issues of these on-premise application deployments where we have the things installed in our own data center is that we have to purchase the hardware that we're going to use to run our applications well before we've actually developed the software often. Now, if you have an existing application, you might already have some good practices for what it takes to run your software. But an additional issue that you might run into is the fact that anytime that you need to do upgrades for that infrastructure, maybe the software has outgrown what it was, you have this high cost to increase. You essentially have to vertically scale that hardware, and that's just a big line item at the start of your software development process. And then oftentimes when you go about configuring and installing the software, you end up having these professional service teams that maybe they just go through a Word document of a list of things that they need to do on the server. So you have a new client and you give them to the professional services department, and they go through the installation of your software, and that's generally pretty cumbersome and error prone. And then on top of that, we end up having IT personnel that are actually managing the hardware themselves, connecting the network, replacing any kind of disks. But the real goal that we want to do is just to be able to deliver the software as efficiently as possible. So how can we utilize the cloud to accomplish some of these challenges? So one of the nice things about the cloud is that it allows us to provision infrastructure as soon as we need it. So there's no long-standing procurement process where we have to go through and say, well, how large is this application? How much hardware do I need? You can actually start small and then grow your infrastructure as you gain additional clients, or as your software grows to meet it. So you can meet the demand of your software's hardware requirements more perfectly. Additionally, the cloud providers allow us to programmatically provision all the infrastructure. So we don't have to have someone plug in the bits together. We can just say, hey, I want a virtual network in the cloud with these subnets that are going to have these different software components running within them. I can specify what network traffic is allowed to and from those subnets. You essentially get this robust system of building your application and describing how the infrastructure of your or what the infrastructure of your application looks like. Additionally, there's a robust set of open source tooling that allows you to easily manage all the infrastructure components, and all the cloud providers have a buy-in to simplify this works, because it helps people utilize their platform. So it's very easy to get up and running with this kind of system. So whenever we're using these cloud providers and we're talking about operations, what features are we looking for? Can I get the next slide? So some of the main features that we're looking for are, we want to be able to have a process that's repeatable. That sequence of steps that your professional services person might go through to, set up the application. We also want to make sure that it's reproducible. Is it just one of those things where, well, it works on my machine? We want it to be able to work across environments. We want it to be idempotent. Idempotency is this capability so that I can actually run the same operational tasks over and over again, and there won't be any side effects. I won't restart machines unnecessarily, or I won't bounce, won't restart the software unnecessarily. I can run it over and over again, and it achieves the same state without modifying anything else. And then this dependency management, when we're talking about all the infrastructure required to set up an application, network port forwarding, the subnets, we don't want to have to really conceptually think of the sequence of tasks that I have to do to spin all that up. We just want to say, I want all this set up, and then just expect it to get done. And we'll talk about some tooling that allows us to accomplish that. Additionally, we want to be able to have a plan for any kind of infrastructure migration that we might be about to execute. So, maybe I want to add a few more servers for testing. I want to be able to make sure that I'm not going to modify or destroy anything accidentally by running through another provisioning process, adding more infrastructure to my environment. And then the last thing is we want to make sure that we have a nice set of state management. So what I mean by this is whenever I go through the process of spinning up all the infrastructure required for my application, I want to make sure that I have a clear end state and that I know everything that was provisioned as part of that process so that I can, view it later on and make modifications to it later on. So what are some methods that, you can go about providing a provisioning infrastructure for your applications? So if we talk about data centers, we're actually kind of manually provisioning that infrastructure, right? We're literally getting the rack or the server, putting it in a server rack, connecting all the network cables and everything, plugging it in. That process is not exactly, easily repeatable or reproducible or any of those operational goals that we really want to achieve to be able to efficiently work and develop our applications. Additionally, some of the cloud providers will offer you this, WYSIWYG configuration. If you log into Amazon, they'll say, hey, you can spin up this, $1 an hour server and just with the click of a button. I find those are similar to like gym memberships where you get started on them and then you kind of forget that you did it and you just end up paying indefinitely. You're losing, what I actually provisioned. And of course, that's not really reproducible or repeatable as well. So maybe you move away from, okay, I'm not going to go manually provision this stuff, but okay, I'm going to embrace the cloud and I'm going to use some, maybe I'll just I'll write some shell scripts to provision my infrastructure. Well, the problem with some of these scripts is that while they might be repeatable and reproducible, at least, you have a sequence of steps that anyone can run in their machine. There's a lot of additional issues that come about when using cloud providers where they actually, will let you know that certain API calls for provisioning infrastructure might just fail. They might not have capacity at the time or something goes on where, that piece of hardware that they were going to provision your infrastructure on had some issue. So it'll just fail. And if you're using these scripts, what ends up happening is that you kind of lose the state of the process if you run into any errors. So you don't know, how far in the sequence of the provisioning tasks I get, and then how do I handle failures unless you've specifically coded for those. And so what I wanted to talk about is there's actually some tooling. In this case, I'm going to talk about a tool called Terraform that allows us to really easily express the state of our infrastructure and how, it essentially gives us this all the functionality that we want when it comes to, provisioning your infrastructure, doing operations, management. And there's other tools out there like Terraform. Terraform just happens to be, an easy example. So can you get to the next slide? So provisioning our infrastructure with Terraform. So one of the advantages we gain here is that Terraform has this generic declarative format. They have their own, language for expressing how your infrastructure needs to look. So all of the different cloud providers, they might provide different APIs to be able to do all this infrastructure spinning up, but they all have different formats. So if you're on AWS, you're going to use JSON. If you're using Azure, then you're going to have this XML format. What Terraform does is it takes a step above that and gives you a consistent way of representing resources and different components of the system with a higher level language that then gets translated into the underlying API for the particular provider. And one of the other biggest sell points here is that you can actually plan the infrastructure provisioning run. So before you actually execute a change against one of these cloud providers, you can kind of take a look and see, oh, it's gonna remove this VM, or it's gonna modify this security group to allow me to communicate over the network on these ports before you actually go ahead and do the run, which is huge, so that you don't accidentally tear down anything whenever you go about setting up additional infrastructure. Additionally, one of the nice things that these cloud providers provide is this tagging mechanism. So if you look over here in the code on the right, I have these tags where I say, oh, this VM, it's for the environment test, and this is just the application machine, we'll call it. And this, you'll see in a minute here how this tagging, the environment tags, allow us to easily be able to produce new environments and be able to configure them differently. So I wanted to give an example of just what running, a Terraform plan execution might look like. So just this one, single line command here, and you can see in this case we're gonna create a new AWS VM instance, and we're gonna create a new AWS security group that allows us to communicate to that VM over SSH. It's very simple, and you'll notice that there's a lot of this computed thing there. So this computed line essentially is Terraform saying, hey, you didn't give me anything explicit for this, but once I go and make the API call, I'll actually calculate what that state's going to be, and then I'll save it on your system for future use. So if you do make any changes, it'll be able to intelligently determine what modifications need to be made. Okay, so now we have the base infrastructure set up, and I like to think of using tools like Terraform and these cloud providers. That's kind of setting a foundation for your application. So now you have this raw hardware, but nothing's on it. You got this blank slate. That's where some of this configuration tooling comes in, and there's lots of flavors of it out there. And Chef and Ansible and Puppet, those are three different configuration tools, and they all have different advantages or disadvantages. But the main takeaway here is that they all represent a way of configuring your infrastructure to install your application in kind of a generic way and a declarative way. So the other aspect of this whole infrastructure and configuration management is that you have this set of scripts that you're able to put into a version control system like Git, so that you're actually able to get a live view of what does the current infrastructure and configuration of my applications look like. And another advantage of these tools is that they can take use of those tags that we used in our Terraform script that we said this VM is for the test environment, and actually do different configuration steps or have different parameters based on that information. So here, if we go, can you get to the next slide, please? So here is an example of using Ansible for utilizing some of that configuration management. So one of the advantages of Ansible here is it's great for small teams, because you can have a single person can manage a large number of hosts just from their own machine. And it doesn't require any additional infrastructure to be installed, or any additional software to be installed on the hosts that you're going to do the configuration changes on. All it requires is Python 2.7, which is pretty much commonly installed on any Linux application or Linux operating system. Additionally, the state transitions that you're using to configure the software are represented using YAML, which is a very common markup language that any developer would be very familiar with. And another nice advantage here is it allows you to group logical hosts using dynamic cloud inventory. And what I mean by this logical host is that it's essentially that infrastructure that you spun up with those tags. So if we look over here on this example and you see this host listing, this first section says, it's going to apply this function to all hosts. But if you look at this section where it's specifying, okay, we're going to install Java 8, the set of hosts that it's going to run against are just the hosts that have been tagged with the name application machine. So this provides a way, in conjunction with the cloud provider, to say, oh, this set of hosts have these particular roles, and I can apply this base configuration to any host that falls into this particular role, which makes it easy to go on and do things like spin up additional test environments, or have a production versus QA environment versus your dev environment. So if we go to the next slide, we can see that here's an example of where I might, want to have different settings for the different environments here. So I can specify these variables to be different between the environments. So let's say I have some Java application, and when I'm running in test, okay, I might be running the latest version. So maybe we're in the process of building our 2.5.0 release. And I can specify, okay, when I'm running in test, I'm not worried about like doing full load. I just want the application up and running. So maybe I utilize a minimum of like 2 gigs of memory to be able to run this application in the test environment. But for the production environment, you'll see that, okay, I'm running the old stable version of the app, which is version 2.1, and I need at least 8 gigs of RAM of memory when I'm running this application. So utilizing the exact same setup, application configuration scripts, I can actually configure different environments just through a few different environment variables. This becomes very powerful anytime that you want to be able to support multiple deployments of your software, whether that's for testing or for different customers, or just a feature branch where you just want to maybe do some kind of like A/B testing or something. You'll be able to configure your software differently. And so with that being said, I mean, some of the big gains here really from moving towards these cloud providers is that you're going to be able to start treating your hardware as more throwaway. And what I mean by throwaway is that you're going to be able to, you're not going to have to worry about the upfront cost of it. If you need, if you no longer need a VM of a certain size, you can just completely dismantle it and reproduce another one without the cost of actually buying a whole new server rack. And then with the cloud configuration stuff, we're actually able to leverage and generically apply our applications installation process to all of these hosts simultaneously, and it essentially gives us this nice ecosystem where we're able to more easily build and deliver our software in an efficient manner. And with that, I'll go ahead and leave it to Sebastian to talk about some of the development advantages.
Thanks, Chris. I think we've seen some great examples of how some of the common complaints with legacy software can be addressed by some of the more modern tooling, allowing deployment to be more agile and to push away some of the operational costs typically associated with that environment. I want to talk a little bit about some things you can do once you've taken care of some of the operational issues and have escaped the on-premise prison. Now, if you're willing to escape the corporate firewall prison, there's some other tricks at your disposal. I'll talk first a little bit about the kinds of things that legacy systems end up with that we can fix by moving them into the cloud. One great example, most of us go to grocery stores, we send out for our own dry cleaning, we answer our own phones, and maybe we have a garden with some herbs in it. But there are some people who have entire staffs to wash their clothes, and they have a butler to answer the door. And what does this have to do with legacy software? Well, inside very profitable places like oil companies or social networks, we've seen clients that imagine they can afford anything. Why buy an IKEA bookshelf when you can call a carpenter from Brazil to spend 6 months with the family, making the most amazing bookshelves ever seen? You may laugh, you think none of us really live in Downton Abbey, but we've seen clients that have done this. We've seen clients build their own object relational mappers. They've built their own message queues. They've built their own windowing systems, string libraries, even databases. And I don't think this is a sin that only legacy software developers commit. It still happens. Every few days, I get on Twitter and read about a group at some startup who reviewed the existing solutions and, quote, decided to go ahead with an in-house solution. That's probably great while they've got $10 million in the bank from their venture capitalist, but maybe now it's a few years later and those options just don't seem as attractive. Maybe it's time to get that IKEA bookshelf. Another very common reason this happens is just they need to be somewhere where the market isn't. This is a picture of the collision avoidance system in the New York subway system, and it's very effective at keeping trains from running into each other, and that was an important problem to solve. But the subway was building it so many years before modern digital computers. These computers are actually just hand wired. The program is wires, and bugs would be actual bugs that cause short circuits between the wires. So, you know, we can't really fault them for doing this. We did have to keep those trains from hitting each other, but now it's 2017, and if you want more trains on the tracks, you need better monitoring software. So often what we see is legacy software implementing proprietary versions of ideas that are now public. There are now software vendors that build solutions to keep trains from hitting each other. There are commercial database providers. There are string libraries you can buy. And the problem you face when you have legacy software full of these proprietary versions of ideas are multiple. So one, your training costs increase. When a new person joins the team, they have to go learn this custom database that you built. Inevitably, like any piece of software, software is not really a manufactured good. It's more like a garden. Weeds grow in it, right? Things change, and the maintenance time you have to spend working on your proprietary versions of that software inevitably displaces the velocity you need to keep up with business changes. And there's a couple pathologies that happen if your team is kind of used to building everything as part of one cozy monolith, which is that they tend to lose the ability to distinguish between tools that are differentiating for them and non-differentiating for them. They tend to couple pieces of the system that don't necessarily need coupling. You know, having built one database, by gosh, we should probably use it everywhere because we built it and it's important and we know how it works. And once you start going down that road, some of the complexity people find when they join the project just comes from those components not acting like they expect. If I've learned 3 different databases and now I join your team and you've built a new one, is it going to work like those others? Has it been tested by thousands of people in the market? Probably didn't quite work the same. So one of the most important things we think needs to be done in a typical very large enterprise system is identifying pieces of it to cut out and replace with public software. I will go through quickly a few examples of the sorts of things we've seen in that regard. And what's notable about most of these is that they're available publicly on the web as a service. And so it's often a necessary precondition to leave that enterprise prison firewall. As an example, a core part of almost any complex business system is authentication. At the end of the day, I need to know who my user is and what she's allowed to do. And what does your development team actually end up having to build? I mean, look at that list on the right. It's not small. And every hour your team spends building that, or even just modifying a library that might come with your Rails or ASP.NET or what have you, is time they're not spending on the core business. Ultimately, for almost everyone, authentication is not a differentiating feature. There's a few providers on the market. We really enjoy using Auth0. Amazon has its own. There's a provider called Okta. If you moved your authentication over to using one of these third-party providers, you're getting a lot of value. You're paying off principal in a sense on your technical debt, which is that they've probably done a better job implementing some of the core components of authentication than you have, because it's their business. Your business is helping your business. Over time, you should reap interest payments as well, in that you're not backing up the password database. You're not continuously improving the login widget for when it breaks on the new version of Chrome. They're doing that. And they're probably doing things you just never had the budget to do, like detecting intruders or building new workflows like email verification of your login. And you probably didn't get the funding to build a really cool panel to show you where all your users are. So it's an example of a component that almost everyone builds into their legacy systems. And at this point, you don't really need to. Another example, a relational database. Now, no one really builds their own relational database anymore, but at the end of the day, even provisioning it is pretty complex. There's probably a whole team that requires change requests and works on backups, works on replicating it, works on getting performance up, makes all the little fiddly choices that any real database requires. You know, wouldn't it be much nicer if you're already in the cloud to use some of the cloud provided databases? So instead of having people on your team that know all the ins and outs of just exactly which instance size you need, which virtual machine you need, and how to provision it, or how to back up, or when to back up, you can just say, Amazon, Azure, I would like a PostgreSQL database of this version, and I want you to back it up every 3 hours, and I want it to be regionally redundant. And you're done. You put it in a Terraform script like Chris showed you earlier, and all the operational concerns vanish. Not all of them. You're still responsible for the performance of your application as a whole, but now a lot of the commoditized detail in managing a database is gone. Another kind of tool that is available to you once you've moved into a cloud is horizontal scaling. You want more capacity only when you need it, but as Chris detailed, if you're building your own machines, the byword there is excess capacity. You're probably wasting operational money. Inside a cloud, there's always features called autoscaling. They have different names with the different providers. They're not magic. They require you to really understand how they work, but they're a fundamental building block once you've committed to provisioning your infrastructure within a cloud that allow you to launch and tear down your servers as your demand requires. You can have more at night or more at Thanksgiving or what have you, which is key to driving down the operational costs of your system, especially if you're operating at some sort of scale, whether that's number of users or complexity of calculations. And this is a tooling that's really only available to you once you've reached kind of some of these other milestones. At this point, everyone then starts to ask, well, that's fine that you said I shouldn't have built my own X, Y, or Z, but at least I'm not dependent on anyone. And I think it's a legitimate question. I wanted to spend 1 minute to address it here. First, the question that we'll ask when people bring this up is, maybe it's okay to be locked in. You were already locked into all kinds of things, your data center provider, or the language you wrote this in, or the services firm that provides backup. This is one more choice, and it should be made carefully, but maybe that's okay. Are you really competing with Microsoft or Azure? If you're worried about that, and I think it's reasonable to be worried about it, a lot of the services now available in these clouds and as third-party services could be isolated. You could very easily imagine, let's say in the case of a relational database, if I'm locked into Postgres, moving the operational systems to a cloud-operated database doesn't lock me in really any more or less. I can assume that roughly similar capabilities will be available across the major cloud providers. If I'd like to move to some sort of fancy cloud-managed database like a high-performance key value store, I can put an isolation layer into my architecture that says, here is the subset of capabilities I'd like to use from that software package, and now I'm free in the future to move between clouds. And the usual caveats provide, if you're looking at getting locked in to a third-party provider, do some research and find the guys that have a lot of money behind them, either because they're proprietary and they've got venture money, or they're a pre-existing business that makes a lot of money, or they're open source. But if you go look at who actually builds it, they're all salaried employees of profitable companies. And finally, we would recommend start with infrastructure type tools like we showed you here. Authentication, databases, provisioning. These are capabilities that are widely available across multiple different providers and will not be as proprietary as some of the other services you may be able to move to higher up in your stack. So to summarize, I wanted to talk about what we said here and kind of lay it out for you in a timeline. So if you want to take some of these tools that we've described to lower the operational costs of your system and lower the kind of development costs by replacing your proprietary pieces with some pieces available in a third party, the timeline we think looks a little bit like this. First, sit down and build a map of what your applications, subsystems, and physical architecture really look like. That sounds really obvious, but at a lot of clients we visit, these systems are so old and so much time is spent just maintaining them and training new people. We tend to have a very oral culture, and a lot of this documentation is well out of date. This is often the first important step to just figuring out what you need to do. Then usually the kind of least objectionable thing you can do that gets you instant results is moving to a set of tooling like Terraform that takes you away from manually provisioning servers to provisioning them in a repeatable way. The payoff here can be really huge. You're much faster to respond to software requirements. If you suddenly need a new test team, you can spin up a whole environment for them. If you want to test a new set of features, you can do that. You can bring up environments now in days instead of the classic IT provisioning process, which in our observation can take days and weeks. If you're there, now you can start provisioning entire environments by actually taking advantage of the configuration tools to install your software or third-party software. Then you can start replacing the non-differentiating components you've got with third-party offerings. This will ultimately reduce development costs as you're no longer maintaining proprietary software that doesn't need maintaining, and you're leveraging the much greater kind of documentation and support resources that those third parties have as compared with your core team. At that point, we'd argue you're kind of able to start a new roadmap where if your legacy app needs refactoring, maybe you're just going to keep some core pieces of it or replace some core pieces of it. You're now in a much more agile state where you can kind of mix and match and blend in a better way with reduced costs, giving you the capacity you need to solve those harder problems. With that, we'd like to wrap up and see if anyone in the audience has some questions for us. And thanks for spending some time with us today.
Awesome. Thank you so much, Chris and Sebastian. That was really great content. So just a reminder, you can send your questions in to me, the organizer. And okay, it looks like I do have a question here. What is a good strategy to go about converting an existing application to be able to utilize horizontal scaling? Chris, do you want to answer that one?
Yeah, I'll take that question. So when it goes to, you have this big application and there's lots of components and there's going to be some issues, architectural issues that might prevent it from horizontally scaling. You're going to have to just take an iterative approach. And this is one of the reasons we're, kind of pushing this idea of being in the cloud, because once your application is already in the cloud, you can kind of start to chip away at these, some of these issues that are preventing you from being able to support that horizontal scaling functionality, but, by replacing small components over time. So, kind of alluding to what Sebastian specified, this could, be maybe you had some kind of, custom built queuing mechanism or something like that, and you just, switch that component out. Maybe it was only done in memory. You switch that component out and you utilize a software as a service queue, something that the cloud providers automatically give you. And then additionally, once you're in the cloud, you can start to, move towards this more continuous delivery model. So as your application gets, broken down more and more piecemeal, you'll start to be able to, leverage more horizontal scaling capabilities.
Awesome. I also have one more. Let's see here. This one says, what are some of the common architectural problems with legacy applications that prevent them from being cloud friendly?
Yeah, so this, I kind of alluded to that in my previous question the previous answer a little bit, but one of the major issues you might run into is maybe you've cached all of your data locally on a single machine. So this kind of ties in with the horizontal scaling a bit, but generally whenever you have any type of cloud application, you always want to be able to run at least two instances of that application on two different machines for high availability, because a lot of these cloud providers actually, will restart your systems if they have to do any kind of mandatory security updates or anything like that to their underlying infrastructure.
So it's possible that your system will get restarted throughout the day. There's certain providers that will give you guarantees that you won't have to restart a system, but you normally want to have this high availability multi instance application running. So if you're using in-memory caches, you would have to make sure that those caches are synchronized. So you can mitigate that by using some kind of distributed cache, which a cloud provider will give you. Some other issues, besides having maybe like custom built queuing or messaging systems that might not be able to support the redundancy that you need in the cloud. A lot of times too, one of the main proponents for going into the cloud is that you can build your application to be multi-tenant. So rather than having, a single installation with different configuration per client that you might have, if you can enable the horizontal scaling and you had the forethought to enable your application to be run with multi-tenants, you can immediately start leveraging the cloud, some of this cloud functionality. But if you haven't gone ahead and set up your application to work that way, you'll have some additional architectural work to do to enable that functionality.
Awesome. Thank you so much, Chris and Sebastian. I think that's a wrap for us today. Just a reminder that part 3, the last part in this series on modernization, will be held July 26th, and you will all be getting an email about that if you'd like to sign up for that one as well. So thanks, everyone. Hope you have a great rest of your week.